So I think where we ended last time was we're pretty much done with this class. I mean, of course, I could think of a lot more functionality to add to it, but we're sort of done with all the important stuff, except I just need to now add the big four, the destructors and the constructors and the assignment operator. So let's give that a shot. First, actually, so everything's working fine now, right? So why do we need those things? So maybe we should work on adding some code here that will break what we have now. What do you think? So what would it have to do? Go ahead.
Assign something to itself.
Okay, assign something to itself.
Isn't that great? It doesn't have to copy.
Actually, at this point, if you assign something to itself, and that'll break if you have an assignment operator overloaded, but you haven't checked for self-assignment. But I think if you don't even have the assignment operator overloaded at all, assigning something to itself will be okay. Right? So the problem we're dealing with here is deep copy versus shallow copy, right? So if you're assigning something to itself, that means you're just making the pointer point back to the same thing it was pointing at before. I think that's okay. The problem is when you make the point, when you do like an assignment or a copy, and you make the pointer, and you, instead of making a copy of what's being pointed at, you just make the new thing point to the same object on the heap. Does that make sense? I didn't say that very well, but we do lots of pictures of it in assignment 3, right? So you've got X pointing to a linked list on the heap, and then you say Y gets X. You don't want that to mean Y just points to the same linked list on the heap. You want that to mean Y points to a copy of that linked list on the heap. And if you don't have an assignment operator overloaded, it just does the shallow copy. So it's pointing to the same linked list on the heap. There, I think I said it better that time. Okay. So, so in terms of breaking it, I guess we should start with, let's do the copy constructor first. So how would we break it? How would we use the copy constructor? We've got a link. We've got a list here named list. So I guess we need another list. So let's make int list type list2, and let's initialize it to list. That makes sense? And then we're going to change list2. And hopefully that won't change list1, right? So list2 dot delete. Actually, let's add something. Add 7. Sorry? Insert, thank you. Okay, and then see out so what I want to have happen here, okay, so see out list2 is now, and then list2 dot print. List is now list.print. Okay, so let's say, for example, that at this point in our program, list, at this point right here in our program, list is equal to 789. Oh wait, no, I inserted a 7. I don't like that. 1, 2, 3. Okay. So what should happen now is it should say list 2 is now 7, 1, 2, 3. List is now, and it should still be 1, 2, 3, right? Okay, let's try it. You know, now that I'm thinking about it, I'm thinking when you guys are working on a project and it comes time for you to write your copy constructor and your assignment operator, you might want to actually go through these steps, because then you'll get to see that your copy constructor is actually doing what it's supposed to do. So I'm going to make a 1, 2, 3. And then I'm not going to find anything. I'm not going to delete anything. Oh, very interesting. Not what I was expecting.
Are you expecting it to add 7 to each?
Yes, I was. So let me think about that for a sec.
Well, the way you explained it, you said the list would be 7, 3, 2, 1, and then it worked just like you said it would.
It worked like I said it would, but that's not what I was expecting. Okay, hold on.
Did it automatically make its own copy constructor that works?
Well, the pointer for this one still points at the whole first item, right?
Oh.
So there's still, it just enters the list further in list 2.
So list, let me think for a sec. So list 2 dot insert. Oh, right. So when we say list 2 dot insert, okay, so let's do something different. Let's delete.
Why don't you add an item to list 1 after?
Or I could just say delete, like the last item, right? Should we try that? Did I forget a parameter? I'm supposed to do, I'm supposed to do found. Oops. Right. Yeah. Okay, so 1, 2, 3. Wait, okay. Oh, nice. This 2 is now 2, 1. Oh, because we deleted the first item. So the 3 was at the front. I did it in the wrong order, so the 3 was at the front. So I was deleting the first item. So list is still pointing at that first item, which we deleted. So it's garbage, right? Okay, so I succeeded in breaking my program. If I just want to see it, if I insert it the opposite direction, 3, 2, 1, that'll be more like what we had predicted, right? Well, now it works. Oh, deleted it from both of them, right? Okay, thank you. Okay, so that's not what it's supposed to do. Whew. Coffee's not kicking in yet. Okay, so we need to fix that. So we go to our header file. And we're going to add a copy constructor. I'm noticing that I don't even have a default constructor here. It'll be interesting to see what happens when, let's just try adding just a copy constructor and see what happens. So int list type const int list type ampersand copy me. Okay, so that's good for our header file. Now our implementation file. I'll just put this at the top. I don't need that many points. Let's see, int, list, type, colon, colon, and then the rest. All right, copy constructor. What are we going to do? So copy me is an object, and it's got, so we could say we're going to be saying dot. What did we call the data member? Dot list. So copy me dot list is a linked list, right? And we need to copy that. We're going to have a loop that goes through, copying one node at a time from copy me to the calling object, right? Okay, so I guess we need a cur pointer that is equal to the copy me dot list, right? That make sense? I guess I should draw a picture. Should I draw a picture? Let's see if we can do it without a picture this time. Any suggestions about what comes next? A loop. I would probably choose a while loop just because I don't know how many iterations there are. Okay, you could, some people would probably do 4, but so while cur pointer not equal null, so that should look familiar by now. So we know that there's a node there that cur pointer is pointing at, and we need to make a copy of it, right? So we're going to need one thing well, here's an observation, right? Now I have to say that I'm completely unprepared today, so I'm winging it here. But what I'm thinking is, well, I know that I need a node, right? I know I'm going to need a new node, so I might as well start there. I guess we'll need a new pointer to the node too. Temp pointer gets new node. Yeah.
What if you said like add a copy me data?
Oh, you mean insert?
Or yeah.
I like that. Oh. And then just cur pointer gets cur pointer arrow next. What do you think?
I can copy the list backwards.
It may, yeah. But order doesn't matter to us, right? Yeah. Yeah.
The parameter to insert should be cur pointer arrow data. Is that right?
Oh yes. Right. Cur pointer. Yeah. Thank you. Cur pointer arrow data. Whoops. Cur pointer. Better. Good thing I have you guys here. How's that look? Should we try it? Yeah.
Should you set, before you enter the while loop, should you set the list of the calling object to null, so that null gets pushed out? Does that make sense? Or no? Okay.
I don't think you have. Oh, let's see. When you insert. Oh, right. When you insert.
So this won't handle the null list. If copying it is new to it, right?
Oh, I see what you're saying. So number one, it won't handle an empty list correctly. Does that make sense to everyone? Okay. Because, well, so if copyme.list is null, then this does nothing, right? So the list data member of the calling object is going to just still be uninitialized, right? I also think that you may be right that there'll be a problem. So what we're saying is we want to start off by saying list gets null. If we didn't say that, the first time we say insert, we're going to have a problem, right? Because if we try to insert something into a list that is uninitialized, we're going to get a we're going to be trying to dereference an uninitialized pointer. Okay, so yeah, good call. Anybody else? Think it's going to go now? All right, let's give it a try.
You can never be for certain at all.
No, that's true.
No, but it's just a little space away.
Okay, so same thing last time. I did 3, 2, 1, right? 2, 1. Okay, it didn't work. Didn't make the copy, right? Am I interpreting the results correctly? Okay, so here's the list that I started with. I'm trying to make a copy of this list. We may have to think real hard about how the insert is working, but so I declare a pointer, cur pointer. Let me do it over here. Yes.
Insert is not copy. Oh, without
Cur pointer.data. I don't think that. Yeah, I don't think the copy constructor is involved there. That's what you're thinking, right? Yeah. Yeah. Good thought. Insert. Okay. So this is cur pointer, right? So this is a good exercise in what you do when you're working on your program and it doesn't do what you want it to do, right? Or will do what you're expecting. So you thought this was going to be a lecture about pointers, really it's a lecture about debugging, right? Okay, so we start off cur pointer equal to copyme.list. All right, and then we say, okay, list gets null. So here's list. And it's null. I'm not going to mark that because it's going to change pretty quickly. Okay, so while cur pointer is not equal to null, so we're going to insert cur pointer arrow data. So cur pointer arrow data is 1, and so we should be inserting it into the calling object, which is here. Let's go take a look at insert. Okay, so in insert, all we're doing is we're saying create a new node, fill it up with the 1 make next. Oh, I guess I should draw that. So here's temp. So temp arrow data. And then we've got a node that temp is pointing at. And we're saying temp arrow data gets 1. And then temp arrow next gets list, which is null. And then list gets temp. Which seems correct. And then next time when we come in to insert, cur pointer is going to be pointing here. And so I'm going to say temp gets another new node. So it no longer points there, it's going to point here instead. Temp arrow data gets num, which is 2. Temp arrow next gets list. So that means this is going to point to the same thing list is pointing at. And then list gets temp. Hold on a sec. Which seems correct to me. Yes?
What's going to happen when we get to the
Never
I thought
mind.
the null pointer at the, since we're reversing list, I thought the null pointer at the end of the list, copying that list would be a problem. That's just going to not go out.
Yeah, it's not going to go in. Okay. So I don't. Drawing the picture has not helped me figure out why this isn't behaving as expected. So what I want to do is let's practice using the debugger a little bit. What do you think?
Oh, yes, sitting great place.
So let's go to our main function, and let's go to.
You said we were supposed to reverse that.
Reverse what?
The 3 in the town.
I don't know what you mean.
Well, how we ended up, we put 3 items in the list, and it's supposed to insert 7 at the beginning of 1, 2, 3, or 3, 2, 1, how it's output. But then when we put 3, found it deletes the first item, and it never really inserts.
Well, that was when it was 1. Because 3. Oh no, I was typing in 3, 2, 1, right? Is that what I typed in?
You switched between them. You started 1, 2, 3, or 3, 2.
Right. So I typed in 3, 2, 1, and then so the list is going to be 1, 2, 3, right? Yeah. And so right here I'm deleting the last item and trying to delete the last item in the list. And I am deleting it, but when I delete it, it's also deleting it from list. even though I thought I had made a copy. So I may just have to sit and think about that. The other thing I might try is I might try just writing the insert function from scratch. Instead of calling insert, actually put the code right in there to do it. Let's just at least trace through this and try to see if we can figure out what's going on, and if not, we'll call it a day and we'll look at it next time. But okay, so let's start debugging. And so I typed 3, 2, 1, right? 3, 2, 1. Okay, so now we're right here. We've got list. Which we could, so we can, if I hover over the list variable right here, it tells me data is 1, and then it tells me that next is pointing to some memory address. Okay, and then if I hover over that, it's going to tell me that the next one after that, the data is 2. And then if I hover over that, it's going to tell me that the next data after that is 3, and that the next after that is null. Everyone see that in the thing there? Okay. And right now, list 2 is uninitialized, question marks. Okay. So if maybe what I should do is I'm just going to step over that and see how it looks after I step over that. So step over. So now if I look at list, let's see if it's still the same. I would assume that it should be. So there's the first data 1, there's the second data 2, there's the third data 3 with the next equal to null. Okay. Now we can actually look at the actual memory locations that it's pointing at too, right? So list 1, actually list, is pointing at 00394A40. Someone memorize that.
You can see it right down at the bottom.
Oh, got it. Oh, thank you. They're still pointing at the same thing? Yeah, they are indeed, aren't they? Very interesting.
So the constructor is in the constructor, that's the problem with,
The copy constructor?
well, whatever that first line was.
Yeah, it was the copy constructor.
Yeah, right there.
That's calling the copy constructor. And if we go look at the copy constructor again, it doesn't seem to be doing what we thought it was going to do. What was the question? What's the next line down?
Oh, you were saying there's no default constructor, but there is inside.
Oh, I had one? Oh.
Yeah, it's just list equals null.
Oh, there you go. You're right. Oh, wait, where did it go? You said you saw it in this file?
Yeah, it's down by.
Oh, there it is. List gets null. Okay, so let's. Good thing I didn't add it. So why does list 2 not start off at null? Someone asked.
Yeah, because when we at the original breakpoint, list 2 was.
Well, it's because we the execution of the program hadn't even reached the point where we were declaring list 2. So hovering over list 2 just didn't, it didn't even exist yet in the, all right, I give up. I'll figure this out before next Monday, and we'll work on it some more. Okay. Right now, let's head down to the lab.